we can start class.
Okay, so test is due a week from today. Homework is due Tuesday night. The school is closed to the public Tuesday for election day. So that means even though teachers have to work, the hub is closed, so y'all cannot take tests on Tuesday. Cannot get help on Tuesday. So we will be here, but y'all cannot come to campus. Monday, and I didn't write it on here, but Monday is the first day to register for spring. So that's the first day you can start registering for spring spring classes. November 5th.
The hub is open, right?
The 5th?
The
Testing room?
Yeah.
On the 5th. And on the
Okay.
7th, but not on the 6th.
Okay.
So yeah, every day that's in green, you can take a test. So you can take a test today, tomorrow, Sunday, Monday, Wednesday, and Thursday. You just can't take it Tuesday. Yeah, they will not let us open to the public on Tuesday. All right, so like I was saying, we had a couple people email us several questions, and I'm not going to go through every one of them, but you can look and see that this is a 4.2 question number 28. So if you're still struggling with your homework or you're still looking through your homework, what I did is I worked through every question and I kind of worked them out to the side so that you can see the answers. Okay, your problems are going to be different. Your numbers are going to be different, but it's going to be the same problem. The probability that two generators fail is the probability that it fails, the probability that it fails. So it's going to be 0.44 or 44 out of 100. Probability it fails, because it's going to fail 2 times. That gives me the 0.196. Now, either it fails or it works. So fail plus work equals 100 or 1. So if it fails 0.1936, it's going to work the rest of the time. So I did 1 minus that to get the rest. Y'all with me?
But the first answer for 2 generators, how we minus 1?
Right here it says 2 backup generators.
Yeah. We find the probability for both generators, the number 8. So we minus 1 minus the probability
Of this
2.
one. Yes. Because we're saying both generators of this one plus both generators of this one equals 1 whole. Equals 100%.
Okay. For 2.
Right. Now, and all they wanted you to do here is say 19% of the time both generators are going to fail. 80% of the time both generators are going to work. So, would you leave your people at that hospital? No, I would not leave my people at the hospital because it's going to fail 19.36% of the time. Now, I again went in there and wrote 19.36, but they wanted it as a whole number. They did not want it as a decimal. Okay? Then, this is one, 4.2, number 24. We are doing 4 adults. So I did an adult, an adult, an adult, an adult. And 66% have health insurance. So I went through and did all of that. Y'all with me? And then here, this is 4.2, number 25. Oh, I didn't write this one down, but I did write it down on yours. We are doing 3 people that have the same birthday. So we are doing 3 people that have the same birthday. So what is the probability that somebody has the same birthday? What's the probability that you have a birthday that's the same as me? 1 out of 365. So what is the probability that the next person has that birthday? 1 out of 365. What is the probability that the next person has that birthday? 1 out of 365. So when I go to my calculator and I do 1 over 365 times 1 over 365 times 1 over 365, Remember, if it has that e to the -8, you're gonna move your decimal 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna be 0.00000, 1, 2, 3, 4, 5, 6, 7, 205. So my answer is gonna be there. Cool? And I have done that for every single one of them. This is 4.2, number 29. This is 4.2, number 30. This is 4.3, number 4. 4.3, number 9. Optional review for the test, number 62. Now for this one, for this one, if it says at least 1 0, this ended up being a not problem. So we had to find the probability that there were no zeros. So if there were no zeros in this problem, then that means that this would be a number between 1 and 9. So there's 9 options. This would be a number between 1 and 9, 1 and 9, 1 and 9. So this is the probability that there are no zeros is going to be 65, 61, which is 9 times 9 times 9 times 9. And the total is 10 times 10 times 10 times 10. Okay? So that is the probability that the answer has no zeros. So at least 1 0, so no zeros plus some zeros equals 1. So either it has a 0 or it doesn't have a 0. So this is like pass and fail, or pregnant and not pregnant. So either it has a 0 or it doesn't have a 0. So this is like 0 and not 0. So my not 0 is 65, 61 over 10,000. My 0 is what we don't know. And together that equals 1. So to get my difference, to get the 0, I subtracted them. So I did 1 minus this. And that's where I got this from. And they wanted it rounded to 3 places. So I did it as a not problem. And then over here I had 4.3, number 19. I had 4.3, number 20. So if you haven't gone through all of the homework, there was like, I think 11 problems that I did right there. These were mainly, the ones I did last time were mainly 4.1 and a couple of 4.2s. These were 4.2s, 4.3s, and a homework review. Okay?
All the time I have a problem with the table. When they tell positive, disease, and negative is really no, like.
False positive.
Yes.
Yeah, those are confusing.
False positive and
Yeah.
false negative.
Especially the one where I had to create my own table. But
Yes,
I
All right.
like false and negative.
Let's look really quickly.
I have one of these.
Okay, hold on, let me look real quickly. Give me just a second. What test is this for? Yeah. All right, hold on. Let me go quickly, just to ease our brain.
would there be any like that on the test?
That's what I'm pulling up right now. Your test is 29 questions, which means they're about 3 points apiece. Okay? So, I'm going through quickly. That one is not. That one has it, but it doesn't say,
It doesn't have the totals.
and it doesn't have the totals. We good?
Yeah.
What is the probability that she chooses the root of 3 specific capitals? We're doing factorials. We good? 8 basketball players, drawing a name out. I gave you a straight, plug it in the calculator, easy breezy. Sequential, that means put them in order. Sequential means put them in order. how many different groups. Now, look, I gave you over here the chart, so y'all didn't have to come up with it.
Okay.
I gave you the chart. Certain forecasts, 3 and 20, express the indicated degree of likelihood as the probability value between 0 and 1 inclusive. Classic counting problems done different ways. Oh, how do we rearrange? This is like the Mississippi problem, y'all. This is like the Mississippi problem. How many ways can we rearrange the letters in Mississippi? You do the total letters over how many D's, how many I's, how many P's. This is the Mississippi. Okay. 4% hard drive. What is the probability you can avoid the catastrophe? What is the probability that you can avoid it with at least? At least, that means you're going to subtract it from the 1.
So anytime it's at least 1 minus whatever.
Probability of getting a green. Okay. The number of possible codes. You've got 5 pins from an 8 keypad key. So that means there's 8 numbers to choose from. Repetition is allowed. We're doing probability, which means what makes me happy over total. I gave you this. I did not give you the totals off to the side. Has to make a delivery at 3 different locations. Go back and look at your notes because we said that what I would say and what they would say is 2 totally different things. I even wrote it in the notes. Ms. Cooper said one thing and they said the other thing. Remember that?
Which one do we do?
I want to say they said that permutation. So this is a permutation problem. Because I said it didn't matter, but they said it did because of GPSing and saving gas and all of that stuff. Marijuana. What is the probability that they did not use marijuana?
This one.
Select all that cannot be probabilities. Probabilities have to be between what and what? 0 and 1. You cannot have a negative probability. You cannot have a probability that's greater than 1. What does P of D represent? There's probably one just like that in homework. Evaluate 7 factorial. That's plug it in the calculator. Tell me if it's significant or not. The probability of being a girl is this. You're doing 4. What's the probability of at least 1? So you're going to do 1 minus this to the 4th power. 1 minus this to the 4th power. We have this. What is the probability of waiting at least 12 minutes or between 8 and 15 minutes? We're doing or, so it's any shading out of the total. I did one just like that last time. Probability not working, probability that they both fail. There's probably one just like that in the notes. That one's straight up, plug it in your calculator. How many different ways? Oh, we did one just like this in the homework last time. We did officers, which means they matter, so that's permutations. We did committee, which is a group, that's combinations. And then we did probability, which is what makes me happy over total. And there's only one way to get the youngest. I did not give you the total. We do a probability given, means you're not using everybody, you're just using the dollar bill ones. And I think we've done that exact problem too. The 4 quarters and the dollar. Now, this is the one where they give you the total. If the totals bother you, don't look at the totals. Mark them out and just look at the inside numbers. So if the totals bother you, don't look at them. Remember, if you use the totals, you've got to take away the double dips. With replacement means we're putting them back in. Without replacement means we're not. Independent means they have nothing to do with each other. Dependent means they do have something to do with each other. That's your test. So, if you were worried about another type of question, that you did not see on your test.
See it? I think for the drug test, the marijuana.
The marijuana test
Yeah.
problem? Do you remember which one it was?
Yeah.
All right, so let's go to do homework,
The review.
the review, and we're gonna do some marijuana.
Yeah, number 68.
Number 38. Now, y'all, another thing, if you get stuck on a problem, hint, hint, and a lot of times there's not a view and example because I pulled it from different books. So y'all, if there's not a view and example, hint, hint, do this. Copy the problem, do Control-C. Come up here and go to Google, Google.com, Google.com. And then once you're in Google, paste the problem. You're probably gonna find somebody who's asked a similar question. You with me? You're probably gonna find somebody that's asked a marijuana type question, and you're gonna find something negative or positive. You're gonna find something very similar. But let's go through and let's talk about this problem. All right, so that's not what I want. I want here, I want to add a page, I want to, I want to get, now, another hint, Miss Cooper is recording everything that we're talking about today. Just saying. So, saying. I mean, everybody's test is different, but Miss Cooper's test is out there. Use the following results for a test for marijuana use, which is provided by a certain drug company. 104 subjects will test positive. That means they said they had the drug. There are 30 false positives. Okay? A false positive means they tested positive, but they're not. Among 159 negative results, 2 are false negative. Okay? If one of the test subjects is randomly selected, find the probability that the subject, so we're only doing one, which means we're doing one fraction. We want to know, or means we're going to include everything. So we want to know that they tested negative. All right. How many total people do we have?
141 plus
We have 141 that tested positive
159.
and 159 that tested negative. Is that 300? Okay. We want to know how many tested negative. Okay. Of the 141 with positive test results, there are 30 with false positive. So all of those are positive results. So 159 are negative, and those are negative within the 159. You with me? So 159 are negative. We cool? 141 are positive, and of those 141, 30 are false positives. So 30 are within that 141. 159 are negative, and 2 are false negative. So this represents all of the negatives. Okay? Now let's go to the other one. Did not use marijuana. Okay, tell me what a false positive is.
Negative?
A false positive
Is negative?
is really a negative. Did not use drugs. Tell me what a false negative is.
Positive?
That is a positive. That is a druggie. So, I need to know how many did not use marijuana. So, of these 141 druggies, were all 141 of these druggies? No. 30 of them were not druggies. So, these 30 were not druggies. So we have those. Do we have any more not druggies?
Yeah.
Those, we would think, were all not druggies, minus the 2. So I could say 159 minus the 2, or 157. So it's going to be,
So why we add
Do 157 plus
159?
30, yeah?
159.
because 159 were the negatives.
But there is 2 false negative from this.
Hold on, are we double dipping?
I don't know, I got lost.
Hold on. 159, because the question says how many tested negative? Hold on, let me go back and look. How many tested negative? 159 tested negative.
But there is 2 false negative with that.
There is 2 false negatives.
I just tried to make it like a table.
Right. Hold on. There's 2 false negatives, which means they're positives, which we have to take away those 2 druggies. So we have to take away those 2. Those are druggies.
So why you make it again in the end? You just have 157 plus 30.
Yeah.
Just only one time.
That takes that and that takes that. And then we don't need those are positive. Hold on.
Oh, look. You gotta check that code.
Negative and those are druggies. And did not, tested negative is that and that. Did not use marijuana. Okay, yes, we've already used that. So 159 minus 2 plus 30. I was double dipping. So it's 159 minus 2 plus the 30 that were in the positive results. That was totally my fault. 159 minus 2 plus 30 over 300. Yeah. Yeah. I was totally double dipping on that one.
Or you can just do the 157 plus the 30.
Right. Minus 2 plus 30 over 300. And is it a decimal? Oh, 3 decimal places, so it should be 0.623.
I just wanna try to make it with.
Like a table?
Yeah, positive, negative, no drugs, using the drugs. Sometimes I'm just confused when they ask about, oh, negative, okay, the negative, but the not.
Positive. Yeah. Yeah, I double dipped on that one.
I just make it like that.
I don't know what I was putting the numbers in.
And when they ask,
So you did positive test and negative test, and you did drugs, did marijuana, and no marijuana. So 141 tested positive. See, I'm not gonna be able to, that doesn't make sense in my brain.
yeah, this is what I'm
The
feeling.
charts confuse me when it comes to these right here.
Yeah.
Yeah,
It's not making sense.
yeah. That one I double dipped on. All right, let's walk away from that one for a minute.
All right, now I will tell you that this chapter, it only has 3 sections. It only has 21 pages of notes. And this is going to be a no thinking kind of chapter. Yes. No thinking. It is going to be calculator based. Okay? Now, what we're going to be talking about is scatter plots, correlation, and regression. Okay? We're going to be talking about X and Y. We're going to be talking about graphing. I did give hopefully everybody a blue handout. And this is steps on how to do this, is problems on how to do this. The book kind of does a crappy job on explaining. So I have notes, but I also have this handout, and I'm going to explain the handout in just a minute. But we're going to talk about the X variable and the Y variable. The X is what we call the cause, and the Y is what we call the effect. It's kind of like cause and effect. The X explains, and the Y is the response. The X is the cause, the Y is the effect. The X is the explanatory or the predictor variable. The Y is the response variable. Okay? And back in some of your math classes, you probably remember doing like an X and a Y chart, like the T chart. We're still going to be doing the X and the Y chart. We're just going to be calling it L1 and L2. We're doing the same kind of thing. Now, also back in math, you learned at some time that when you plugged in like 1 into an equation, you got an answer. And when you plugged 3 into an equation, you got an answer. And then when you graphed those points, those X and Y points, it made a line. And you were told in math class that you always wanted it to make a line. Well, in real life, it's not always a line. Sometimes it is a line, sometimes it's not a line. And we're okay if it's not a line. So what we're going to be doing is the same kind of thing, but ours are going to be scatter plots, which means that sometimes they're going to be a line and sometimes they're not going to be a line. They're going to be scattered. Okay? So we don't deal with, back in Math 101, you had 4 quadrants. You had your x-axis, you had your y-axis, and your line kind of went through everything. In this class, we're only going to be dealing with the first quadrant because all of our data is usually positive. We have a positive x and a positive y, so we're only going to be dealing with data here. So you're going to notice that I usually only draw this first axis because we don't like to deal with negative numbers, even though businesses sometimes have negative numbers. So you'll notice that I only draw the x-axis and the y-axis, and I only deal with like that first quadrant. So my data may look like that. It may not be a straight line, or it may be a straight line. We cool? And sometimes my x and y, instead of being up and down, sometimes they write it side by side. So instead of me writing x and y this way, they wrote the x and y this way. They just turned it on its side. Okay? Now, what we're dealing with is how do these two things relate? This is called a correlation. A correlation is how do they relate. So I want to know, how does age and vocabulary relate? So how old you are, is there a relationship between age and how many words you know? Okay? I hear yes. A 3-year-old knows 540 words. A 5-year-old knows 2,100 words. So we took some data. How old are you and how many words do you know? And we graphed it. Okay? A 2-year-old knew 220 words. So a 2-year-old, 220 words. A 6-year-old, 2,500 words. And we graphed all of these pieces of data. And we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data that we graphed on this line. We good? Now, for this one, it actually was pretty linear. It was a pretty much of a line, and the more linear it is, the better it tells us that it's a relationship. Now, if these dots were all over the place, that means it's not a good relationship. Like if I said, your IQ and your hat size. Is there a relationship between how smart you are and your hat size? No, there's no relationship. So if I took your IQ and how big your head was, and I took everybody's and I graphed them,